Okay, next group going will be transitional elements. Okay. Mary, where are my transitional elements? Where if I?
They're located in the middle.
Yeah, it's this whole middle block right here. This is all of your transitional elements. Why do we call them transitional? What are we doing? What are we transitioning from and where are we going?
I don't know that question, but
Okay.
transitional elements are elements having a partially filled B or S subshell in any common oxidation state.
Nice. All right, that's a little deeper than this class. Okay, so partially filled E and D shells.
Yeah.
Yeah, that's definitely above the pay grade of this class. All right.
Oh, I thought that's good.
Oh, that's a good thing. That's good. All right, keep going. So what are some other things you guys learned about these elements?
I'm gonna start with the fun facts.
Oh, okay, good.
Okay.
We're getting a little technical and boring here.
Iron, cobalt, and nickel are the only elements found on the periodic table that can produce a magnetic field.
Okay. So we'll say some form.
Yeah, I needed to know that.
Actually, that's kind of important.
That's what I'm saying, I needed to know it.
Yeah.
Being rude.
In fact, if it wasn't for the iron in our core, we wouldn't have a magnetic field. And if we didn't have a magnetic field, you guys wouldn't have cell phones.
Do you know why I'm allergic to nickel?
Why?
Like what? I don't know. I'm asking you why someone would be allergic to nickel.
Not really sure. Never heard of that.
Well, I am.
Well, I know that some people's skin don't react well with different types of metals, and you get like their green ring around your finger.
Well, I'm allergic to metal, so that's a fun fact.
To all
I mean,
metals?
nickel.
Nickel?
Okay, next.
That's interesting. Okay.
This is a long one. Most elements can only use electrons from their outer orbital to bond with other elements, but traditional metals can use the two outermost orbitals to bond.
Now that's worth mentioning here. So in our transitional elements, we can not, we're not just using our outer shell, we're using the two most outer shells for bonding. That's actually a good one.
They have high melting points.
Okay.
And they form colored compounds.
And they form what?
Colored compounds.
Colored compounds?
Yeah.
That's interesting. In fact, a lot of our heavy metals are found in the transitional elements, right? I think about those types of metals that we are very worried about in terms of getting into our environment. It's actually, that's pretty much where you're going to find them at. They're very toxic, some of them. But what's really interesting with some of the transitional elements too, speaking about the colored compounds, is what they use in the art departments to get the different glazes and get the colors of glazes. Those are actually due to some of these elements. Go ahead. Anything else?
Oh, there's 38 elements in the group. Groups 3 through 12.
We'll keep that down. I think that'll be our last one. So we're groups 3 through 12.
And they're good heat conductors.
Okay, and we're good heat conductors. All right. I do want to mention here, my biggest thing I always say with transitional elements, they don't play by the rules.
No, they have many oxidation states. Does that have anything to do with what you just said?
Yes.
Okay, good. I thought
Remember yesterday we talked about how to use the periodic table to figure out which two elements we're going to bond together, figure out the charges. Okay, the transitional elements don't play by the rules. In fact, iron has 3 different charges that it could possibly have. So when we think about lithium, lithium is always going to have a +1 charge. Iron could be a +1, it could be a +2, or a +3. And so a lot of times we just call those iron 1, iron 2, and iron 3. So it's kind of interesting with that. All right. Metalloids. Who has metalloids?
We do.
All right. I want to hear from Hope first. That way I can make sure she's staying off our website.
Okay. There's boron, silicon,
Okay, boron, silicon, or blah, 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 right? Germanium. Alright, so if I look at my periodic table, it's this diagonal come down through here, right?
Yeah.
Alright, so we've got boron, silicon, germanium, arsenic, tin, selenium, polonium,
That's ancient, or the last one.
and then I can't remember that one. Acetine, antimony or antimony.
And they're like, and they're usually shiny, gray, white, or brittle.
Okay, so they're shiny, they're gray and white.
Yeah. Sometimes they have a blue tint to it.
Shiny, gray, and white. Alright, what else you got?
They can be brittle.
Oh yeah, these start to be brittle. But guys, what's really happening here is we're moving away from metals and we're starting to move into non-metals. And that's kind of important because now we're going to start losing our metallic properties. So what did you guys find out about some of the metallic properties of these?
It says that they can carry an electrical charge.
So they can carry electrical charge, but they're not necessarily great conductors of electricity. Okay, so now what we're starting to get into is we're going to lose some of that metallic. They're brittle. When we think about metals, metals are pretty ductile, they're bendable, they're flexible, right? They're malleable, which means we can pound them into different shapes and get them out to flatten out to nice thin sheets. It's called malleable. These are brittle, which means they break very easy. It's not a type of material that you're going to be able to fold into different shapes. So we're starting to move away from our metals and we move into the non-metals. Any others that you guys want to share from metalloids? I do want to mention here that they actually have both properties. They have properties of both metals and non-metals.
Well, it says somewhat cross between.
It says that they have both metals and non-metals. Well, all, yeah.
Guys, quiet down, please. All right, so that's kind of the key one right here, is that your metalloids have properties of both metals and non-metals. Perfect bridge. All right, let's talk about the halogens. All right, for group 17. Chlorine. Chlorine was the first discovered. Probably the first used in the biologic war. World War I. Chlorine gas bombs. Anything else?
They mean a salt form, and they contain compounds containing it, call them salts.
Alright, so they form salts with the alkali metals. Okay, you guys remember NaCl? Sodium is an alkali. Chlorine is a halogen. When they form together, we have salt. Alright, and chlorine was the first discovered.
Does salt have sodium in it?
Sodium chloride.
Okay.
Which is why, okay, honestly, when you're like, having to watch your sodium, what they're really trying to do is watch your salt intake. And if you read the side of the box that says, here's your sodium content, it's almost always because of the salt that's involved in that box.
You're making fun of me.
Don't mind. That's a great question. Now guys, the sodium chloride is not the only salt we can have, right? We can have a whole mixture of different salts. In fact, the salt that most of you guys are putting on your driveway is actually potassium chloride. You guys ever use that for the sidewalks? It's usually a type of rock salt. It's potassium chloride. It's not good for you to eat that.
That's why they told me not to eat.
Yeah. Good job. And the salts that you guys put in your water softener, again, that's going to be a different type of salt than table salt. So if you want to, don't feel like you're paying the money for salt, don't go and buy a bunch of table salt and pour that in there. It's not going to work out too well. Okay. Not really sure. I had some guesses, but I'm not really sure. Alright, anything else about halogens?
They each have one electron missing, which means they're negative ion.
Okay, so we have a -1 charge. We're gaining new electrons. Where do we see halogens used? What? No? No. Not those types of salts. Tanner. Now you're done. Close your laptop. Alright, guys, think about this for a minute. Where do we think about halogens? When you guys think halogens, what do you think? Wow. Headlights?
Honestly, I think of sounds like Halo, and then maybe possibly Angel. So I think of the Halo generation.
Wow. You guys ever heard of the halogen headlights?
No.
Halo
Halogen lights?
Yeah, they're really, really bright.
Yeah, they're like when you're driving down the road, those are the stupid little purple lights
Oh
that
my
blind you.
God.
Yeah, those are
I didn't even
halogens.
bright them, and they're not even have their brights on. It's just
Yeah.
like,
Yeah, Halo lights are really good.
Okay, that's the halogens. Okay, so when they get electrically charged, they actually emit tremendous amounts of light. And again, it's because they're very reactive. The other thing I want to mention is that these are your mixes with hydrogen to make acids. So HCl, hydrochloric acid. And then you can also have fluoric acid, HF, hydrofluoric acid. Okay, so these they mix with hydrogen. Again, it's really easy. Hydrogen has a +1 charge, chlorine has a -1 charge. Therefore, bond really easy. And what's interesting about that is when we go back to our periodic table, unlike the metals, where we get more reactive as we go down this side, on the other side of the periodic table is actually the complete opposite. It gets less reactive. So you actually are more reactive as we move up the periodic table. So hydrofluoric acid is much worse than hydrochloric acid. All right, and then the last thing we need to talk about are those pesky noble gases. Group 18, all right, so noble gases, we're group 18, we're in the last column. All right, what else can you tell me?
They're odorless.
Odorless,
They are room temperature.
odorless, and they're at room temperature? I disagree with that.
They're highly unreactive.
Okay, they're almost absolutely non-reactive. In fact, the only time that they're reactive is if you send an electrical current to them. Okay, so think about one of the key gases that we have there is neon. Neon lights. Okay, those are actually tubes of glass that are filled with the neon gas. And by sending an electrical current through the glass, or through the gas, it actually excites the electrons and we have light that's emitted from that. So, and so remember from the video, they were talking about the fact that they had the rubidium that was surrounded with argon. Okay, why would they surround the rubidium with argon? Why not with oxygen?
There's no oxygen. It could react because it reacts with water, which is oxygen. So if there's no oxygen, in
Yeah. Rubidium only has that one extra electron, readily wants to bond, and so therefore you have to put it into an atmosphere that is not going to allow it to bond. So since argon and gas already has a full outer shell, it has no need to react with that rubidium. And therefore, a lot of times with those really strong metals, we can create a safe environment by encasing it in the gas. Okay. Any questions on that, on those different groups of the periodic table? Now, there's one thing we haven't really discussed yet, and that is how to take this and build a model for atoms based on this.